Okay, so today we're going to move on to rational expressions. Okay, rational expressions. Now, a rational number is any number that can be written as a fraction. That's how we define rational numbers. We did that all the way back in Unit 1, defining numbers. Okay, so 2/3, 7/4, 11, 12, doesn't matter what the numbers are. That's what a rational number is. It can be written as a fraction. So when you talk about rational expressions, it's easiest just to think of it as looking like a fraction. So you got your nice little fraction bar, x over y. They can be single variables. They can be different variables. They don't have to be the same thing. I can have an entire expression divided by a number. I can have an expression divided by another expression. These are all considered rational expressions because they're written out as fractions. Okay, so that's what we're looking at, rational expressions. This is going to be a two-part lesson. We'll do our first unit is going to be rational expressions part 1, and then we'll do a rational expressions part 2 where we get a little more complicated. Okay, so not really complicated, it's a little deeper, that's a better word. Okay, so when you're talking about these things, simplifying or writing a rational expression in lowest terms. So we want to be able to simplify these things, just like if we had 2/8, I would want to be able to simplify this. I would reduce each one of these divides by 2, so I get 1 and 4. Okay, so I get a 1/4 as my fraction. Well, we want to do the same thing, but with these kind of things, where I have my rational expressions, I want to be able to simplify them. So, for instance, when we look at step 1, we're talking about completely factor the numerator and denominator. Okay, and we don't mean together, we mean separately. You'll factor the numerator, factor the denominator. Okay, of the rational expression. So you're talking about factoring the top, factoring the bottom. It says completely, meaning you need to take GCFs out and everything else. If you have the difference of squares, you need to factor those as well. Cubes, they all need to factor. So you factor it out as much as you possibly can in both the top and the bottom, the numerator and the denominator. Okay, and then step 2, you just cancel out factors that they have in common. Okay, just cancel out factors that they have in common. So if you go back up here to our 2/8, which we reduced to 1/4, essentially this is saying I could have had 2 on top, and on bottom I could have done 4 times 2. Okay, and essentially what's going to happen is I'm going to cancel out my common factors. Remember, we never cancel something completely. We always put a 1 in its place. Thus, I get the 1/4. Well, we're going to do the same thing, only now we're going to do it with variables and expressions and things like that. Okay, so there's a little example here, just kind of talking about the fact that negative a over b is the same thing as a over negative b, which is the same as negative a over b. Okay, that's super important when we're looking at these things. We can always take that negative, it can be on top, it can be on bottom, or we can pull it all out in front. It all means the same thing. Okay, now if I put a negative on bottom and top, that's something different because a negative over a negative makes a positive. Okay, so looking at it with expressions, if I have a negative on top, negative on bottom, same thing as that negative out front. Okay, that's super, super important. That's going to help us when we start trying to cancel these things. All right, so let's take a look at our first example. 24x to the 6th, y to the 5th, divided by 8x to the 7th, y. I know it looks scary, but it's not so bad. Okay, this right here, we're just going to reduce. Starting with that 24/8. How does 24/8 reduce? Okay, meaning what goes into both. So I can divide both of them by that 8, right? I can divide by 8, divide by 8 there. Okay, so they're going to reduce. So I'm going to end up with 24 divided by 8 is 3. And on bottom, I end up with a 1. Okay, and then you do your x values, which we've already done this when we looked at rational expressions. Remember, we're going to cancel out the smallest, so I have x to the 6th and x to the 7th. So we're going to get rid of the x to the 6th and subtract that from your bottom number. So 7 minus 6 means 1x is left. Same thing with your y values. Whichever one has the smallest exponent, so y to the 1st or y to the 5th, we're going to get rid of the smallest and subtract it from the larger one. So that's a y to the 4th, which is up top. Okay, that's super important. You have to make sure that your they stay in the correct spot. So whichever one had the largest exponent, okay, that's where my variable should stay. Okay, just show you a different way of looking at that exact same thing. If that's confusing for you, you can always take these things and write it out. So 24, I can break into 8 and 3. 8 breaks into 4 and 2. 4 breaks into 2 and 2. Okay, factor tree there. Same thing with my 8 down here. I get 4 and 2. That's a 2. And I get a 2 and 2. Okay, so when I go to write this stuff out, on top I would have 3 times 2 times 2 times 2. Okay, I've got 1, 2, 3 2s, that one we used, and a 3, the 8 we used also. Okay, so 3 times 2 times 2 times 2. Now I've got 6 x's. 1, 2, 3, 4, 5, 6, and 5 y's. 1, 2, y, 2, 3, 4, 5. Okay, I could literally write this all out. Do the same thing for the bottom. So I've got 2's. I've got 1, 2, 3 2's. 2 times 2 times 2. And I've got 7 x's. 1, 2, 3, 4, 5, 6, 7. Don't know why I can't write my x's and my y's today. 7. Okay, and then I've got 1 y. I think I was just jumping the gun. Okay, that's taking this up here and just writing it all out. Then you would just go through and cancel through everything that you can find that matches. There's a group of 2's, group of 2's, group of 2's. Same thing for the x's. 2, 3, 4, 5. Everything that's got a match you cancel. Okay, and then whatever's left is what we have in our answer. I've got a 3 on top. And I have 1, 2, 3, 4 y's. Y to the 4th. Over, and I had 1 little x left over on the bottom. Okay, that 1, of course, is not necessary. You don't have to put a 1 in front of a variable. So, 3y to the 4th divided by x. That is our answer. This takes a little more time, but it's a little more concrete. So if you want to do that, you are always welcome to do that. Okay? So moving on to B. Okay, notice that the very first step says that we have to factor these things completely. Okay, both the top and the bottom, numerator and denominator. So we just spent a whole lot of time, like 4 weeks, I think, or something, learning how to factor. So that's what we're going to be looking at doing. On top, I've just got 2x squared, so we can't do anything with that. Okay, but on the bottom, I have a GCF. Okay, 10x cubed and 2x squared has a GCF of 2x squared. Remember, you always use your lowest exponent. Okay, so I've got a 2x squared, and then we got to write out what's left. Okay, 10 divided by 2 is 5. I have 1x left because I had 3. I took out 2. And then minus, remember we have a 1 left there. If I take out the entire thing, I have to keep a 1. 2x squared divided by 2x squared is 1. Okay, if you're struggling with that, you need to go back and look at Unit 10, Unit 11. There's a lot of factoring in those two units. From there, you just have to see what cancels out. I've got a 2x squared and a 2x squared. Those are both gone. Okay, those are both gone. Now, be very careful here. All I have left is this 5x minus 1. But the 5x minus 1 is in the denominator. Okay, it's on the bottom, and it needs to stay on the bottom. I can't let this thing magically float its little happy way back up here. So on top, we put a 1, because when I reduce, I should technically put a 1 there. So 1 over 5x minus 1. That way we can see that 5x minus 1 is still down in the denominator. Okay, so don't let these things magically float their way up. Make sure that if it was in the bottom, it needs to still be in the bottom. Okay, so next one, looking at C. Okay, if we take a look at C, now these are really close, but they're not the same, so don't jump the gun here. I've got 2 minus x and x minus 2. To cancel, they have to have the exact same signs. Okay, they have to have the exact same signs. So I can't cancel this. This has a negative x, this has a positive x. That doesn't work. But if you remember from factoring, especially the factoring by grouping the split the middle, if I take a negative 1 out of this and factor it out to the front, okay, what's behind it will change signs. I will get negative 2 plus x. Okay, both things behind it will change signs. -1 out front, -2 plus x. If I were to multiply this back in, I'd have -1 times -2 is +2. -1 times x is -x, so I would go back to my original. Okay, that's over x minus 2. Now, if you look at that, now I've got x minus 2. Okay, it's okay that they're written in the opposite order. I can rewrite this to say x minus 2, which I'm going to just so you can see. Okay, x minus 2, -2 plus x, and x minus 2, same thing, just like 2 plus 2 and 2 plus 4 and 4 plus 2 are the same. Yes, it helps to use different numbers, huh? 2 plus 4 and 4 plus 2, they give me the same answer, same thing here. As long as you take the sign with it. This is a -2, so when I move it, it still needs to be a -2. Now this is still over x minus 2. Okay, well I have an x minus 2 on top, and I have an x minus 2 on bottom. Okay, so I can cancel those out. They have to be identical, and it has to be multiplication. That's super important. There has to be multiplication in here. That's why I'm allowed to cancel out this whole entire thing. So x minus 2 over x minus 2, which would leave me -1 over 1, which is just -1. Okay, that's just a -1. So looking at D, same sort of idea. Start with the top. We need to factor the top. Okay, we need to factor the top. So looking at the top here, okay, just the 18 minus 2x squared. That's what we're going to start with. I have a GCF. I'm going to make it a -2. Okay, I pull out a -2. That way I end up with a positive x squared minus 9. Okay, let me do that again. I'm looking just right here at this top. If 18 divided by -2 is -9, and -2x squared divided by -2 is just positive x squared. I went ahead and I just switched the order so that my x squared came first. Okay, you can multiply this back in. I get -2x squared, and -2 times -9 is positive 18. So I do go back to my original. Okay, and I went ahead and just switched this here, and I'll show you why in just a minute. So on bottom, let's go ahead and factor it. This is a target product target sum. Target product is -3. Target sum is -2. Two numbers that multiply to -3 but add to -2 is going to be -3 and +1. Okay, those would multiply to -3, but they would add to -2. So when I factor on bottom, here's our shortcut we learned in the last unit. We get an x in both, and we get a -3 and a +1. Now remember that this only works, the shortcut only works if I have a 1 in front of x squared. Okay, the shortcut only works if there's no number out in front of x squared. If I have like a 2 or a 3 or any other number out there, then I'm going to do split the middle. But since I don't have a number in front of x squared, we can just jump the gun and do the x minus 3, x plus 1. Okay, we're still not done. It says factor completely. This is the difference of squares. This is the difference of squares. X squared is a perfect square, 9 is a perfect square, and it's a negative. So we need to actually square root x squared is x. We are going to square root 9, which is 3. Okay, so that top part, we're going to get -2, x plus 3, and x minus 3. So one more time, that x squared minus 9, it is the difference of squares. So we take the square root of both terms. X, the square root of x squared is x. The square root of 9 is 3. And we get x plus 3, x minus 3. That's how that factors. And that -2 is still out front. All of which is still over x minus 3 and x plus 1. Okay, so now we've got it completely factored. Now we can cancel out matching terms. So I've got an x minus 3 on top and bottom. They can go away. Everything else will stay. X plus 3 over x plus 1. Now you can keep your parentheses on the bottom if you want to. You don't have to because there's only one term on the bottom. When there's two terms, you have to have parentheses. Here I've just got the one. So it's okay if you don't put the parentheses on it. Okay, it's okay if you do, it's not a big deal. So E. Okay, E. My screen turned off, 1 second. Okay, so E is going to look the same way, and now there's just a little more factoring happening in E. Okay, there's a little bit more factoring happening in E. So, let me kind of block this off so we don't get it all mixed up with our other problems. Okay, so looking at E, starting with the top, target product, target sum. Okay, my target product is -6. 2 times -3 is -6. My target sum is -5. Okay, -5. So my two numbers that multiply to -6 but add to -5 would be -6 and +1. That would multiply to -6, add to -5. Now here I can't shortcut. I've got a 2 in front. So we're going to have to split the middle. 2x squared minus 6x plus 1x minus 3. Again, if you're having problems factoring, go and look back at the factoring videos. Okay, so we're going to go ahead and factor by grouping here. Notice that I'm just working with the numerator at this point. Just working with this top part. Okay, I'm going to get it fully factored. So I got a GCF here of 2x. That gives me x minus 3. Here I don't have a GCF, so we just use 1. We've got an x minus 3. Take that x minus 3 out of both. I get x minus 3 and 2x plus 1. X minus 3, 2x plus 1. Okay, so this is the top factor. This right here is all numerator. All of this is the numerator. Okay, and I'm going to go ahead and label that, and I'm going to leave it. This is my factored numerator, so that's part of it I need. I also need to factor the bottom here. Okay, I also need to factor the bottom here. So I've got x squared minus 4x plus 3. Target product is 3. Target sum is -4. So my two numbers that multiply to 3 but add to -4 would be -1 and -3. Okay, negative times a negative makes +3. Add those, you get -4. Since I have a coefficient of 1 in front of my x squared, I can do the shortcut here. We don't have to do split the middle. We can just jump straight to the x minus 1, x minus 3. If you don't like the shortcut or you don't know when you're allowed to use it and when you're not allowed to use it, do the split the middle. Split the middle works every time. That's why we taught you that form. Okay, so just do split the middle. But if you're comfortable using the shortcut, it does make things a little bit faster for you. Saves you a little bit of time. Okay, so this is denominator. And yes, I am labeling it mostly for your notes. Okay, you don't have to label it when you're doing this, but do make sure you keep straight which part is your numerator, which part is your denominator. So now I've got my two factored pieces. I'm going to put them together. X minus 3, 2x plus 1. That's from right there. And that's over x minus 1, x minus 3. Okay, that's that piece right there. So once we're here, now we can go ahead, cancel our common factors. I've got an x minus 3 on top and bottom, leaving me with 2x plus 1 over x minus 1. Okay, again, you can keep your parentheses. You don't have to. This time I'll leave it without the parentheses just to show. Okay, so equals 2x plus 1 over x minus 1. So that would be your final answer. Okay, so that's a big part of it, is just making sure you can factor. If you still can't factor, you need to come into tutoring. Make sure you're getting help. Look back at the videos from Unit 10. Okay, that's where we taught you how to factor, was back in Unit 10. Go over your notes for Unit 11. There's lots of factoring in there also. Okay, you have to be able to factor because that's the only way this stuff works. Factor the numerator, factor the denominator, cancel common factors, and that's how you deal with these things. So I know the rational expressions look kind of ugly because they got those fraction bars, okay, but they're really not that bad. Now I would suggest that you pause this and go ahead and try both of these your turns on here. Okay, give them a shot and then hit play again and see if you can get the same answers that I get. Okay, I'm going to go ahead and just keep on going, but remember, you have a pause button. Go ahead and hit pause if you want to. Okay, when you come back, I will still be here. Alright, so moving on. 40a, a to the 7th, over 16a to the 10th. So same thing, start with the number, we're going to reduce it. Okay, start with the number, you're going to reduce it. You have to figure out what number goes into both 16 and 48. Okay, I'm going to give you a little demonstration here. Let's say that the first number you can think of is 8. 8 goes into 16 twice, and 8 goes into 48 6 times. Okay, 48. But then you get to this point, don't just immediately say, okay, I found a number. You have to check, do these numbers have a common factor also? They do. Okay, so then I could reduce, because 2 goes into 6 also. So 2 reduces to 1, and 6 reduces to 3. Okay, now here, we're at our final end, because 1 and 3, they don't reduce anymore. So just because you can't immediately figure out the greatest common factor between 16 and 48, start with the common factor, and then work your way down. You can keep breaking it down. If all you saw was 2 went into both of them, break them both down by 2. And then break those numbers down by 2. Once you keep doing that enough, eventually you will end up right here at 3 and 1. Okay, so I've got 3 on the top, 1 on the bottom. Here I've got a to the 7th and a to the 10th. So I'm going to get rid of the smallest and subtract it from the largest. Okay, so up here in the top, I end up with a 3. And on bottom, I've got a 1. A to the 3rd. We don't need the 1, so I'm just going to write the a to the 3rd. So 3 over a to the 3rd. That's your final answer. B has the same sort of thing. Okay, but now we've got to do all the factoring, starting with the top. Okay, and I'm going to actually do mine over here on the side. X squared minus 4. Okay, this is perfect square, so square root of x squared is x. Square root of 4 is 2. So I get x plus 2, x minus 2. Okay, that's my numerator. Then I'm going to do my denominator. I have a GCF of 2 here. 2x squared plus 8x plus 8. I can take a 2 out front. And I've got x squared plus 4x plus 4. Okay, looking for target product, target sum here. Okay, target product is 4. Target sum is also 4, so 2 times 2 would multiply to 4 and add to 4. And now I've got a 1 in front of x squared, so I can go ahead and shortcut that. X plus 2 and x plus 2. Okay, x plus 2 and x plus 2. This is my denominator. Okay, got my numerator factored. Got my denominator factored. Put those two together. So x plus 2, x minus 2 on top. Okay, and then you have 2, x plus 2, x plus 2 on bottom. Now be very careful here. Okay, the x plus 2's, those two things match. We cannot just cross these out because they look close. One is a minus, one is a plus. Now if you're wondering, can I just take a negative out of this? If I take a negative out, then I would be left with negative x minus 2. Both would have to change signs. Okay, and negative x minus 2 does not match x minus 2 either. So you can't just take a negative out. So that's just going to be your final answer, x minus 2 divided by 2 times x plus 2. Now, if you chose you wanted to actually multiply that back in, that's fine. That's not going to hurt anything. But I'm going to leave it just like that. That would be my final answer. That should let you do... once you're done with that, you should be able to do none of the above. So you're not going to be able to do the homework just yet until after we cover the lesson on Friday. So that's your basics. That's your intro to rational expressions.